Okay. Hello. Hello. Mic check. Mic check. Hello. 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 Mic check. Mic check. Hello. Okay. I think I'm audible. Maybe need to increase the volume a little. Just a little. Okay. Let's go. So, this stream will be more like we'll be learning a lot. Basically, we'll be reading a lot. I've been going through my code and uh, I'm not sure what I did here last time because I've forgotten most of the bit masking stuff. And I watched a YouTube video, and based on that, I'll try to explain things. Okay. I've also not solved a lot of questions, and I think it will be a challenge for me. So let's see. Elevator rides. Basically, uh, in the question, you see that we have n people, and we want to take them to the upper floor, right? And we have maximum limit on the elevator, maximum weight limit on the elevator. So the question is basically that the minimum number of rides that will be needed to take all of the people to the whatever top floor or like their destination. So you see, if we try to do it like uh, first thing that comes to mind is that we can try all the combinations, right? All the combination of people, and then we'll see which combination gets us the minimum number of rides, right? But if you see that we have n is equal to 20, right? And for all the combinations, it will take like 20 factorial, and that is not something our computer can handle. Okay, elevator rides. So we have been given this input. Let me copy it, paste it, enlarge it. Okay, and you see that okay, so red pixel. We have the weight limit on it. Okay, it is 10, and we can try a different combination of people to take to the upper floor in a single ride, right? And since there are four people, that can be 4 factorial, that is 24. But yeah, 4 factorial. Let's say we have 4 is the only person here. So we can directly take him since the maximum weight limit has not been reached. So if 4 is the only person, then he will take only one ride. Similarly, for 8, 6, and 1, also we have 1 as the answer. Okay. But what if we have combinations like 4 and 8? Then in that case, we will need two rights at least. If we have 4 and 6, then we can take one. If we have 4 and 1, then we can take one right only. If we have 8 6, then we need two. So this is all like two people combinations. And if we have 4 8 6, okay, 4 8 and 6, then we need to not only know the answer for this but also calculate if we add 6 in the roster as well. So we know that for 4 and 8 it is 2, and for 6 it will be one more, so it will be 3. So how am I calculating this, right? So the DP state that you would like to work on with is that we have a DPI which tells me that what is the minimum number of writes and what is the last ride weight that we have. Okay, so before that, since we are like going through all the combinations, right? There is an efficient way of doing this simply by using a bit masking. We cannot go through all the n factorial combinations. Or right, n factorial arrangements or n factorial combinations. What is it that we want to don't want to do? Okay, let me. Okay, yeah, it is arrangements because you see, if we have 4 8 6 and if we have 4 6 8, the answer will be different for this, right? Suppose we are taking 4 and then 8 and then 6, then for this the answer will be 3. But if we are taking 4 6 and 8, then the answer will be 2, since these two can be grouped up, right? So not only we have to like choose the people but also their order matters here, right? uh yeah. Okay, so it is kind of like an factorial different combinations. So instead of going through all the n combinations, why don't we just uh, go through all the subsets that we have? So suppose 4861, right? The subsets that we have are basically 4 8 6 1, 2 to the power 4, that is 16 subsets we have. Then we have 4 8 4 6 4 1 8 6 8 1, then we have 6 1. Okay. We have 4 8 6 4 6 1 8 6 1. Okay. We have 4, 8, 6, 1. So how many? 4, 6, 10, 14. Two more. We also have the choice of not choosing anyone. Uh, this. And I think we're missing one. Wait, I think we're missing one. What is it? This there should be one more guy here. Yeah, it's 481. Okay, so we have 16 different combinations, right? So we'll iterate through this and then try to make the rights. Okay, so for these case, and then okay, so our DP will be like this DP of I, where I represents the subset. Okay, and how we are going to do it? We're going to simply use a bit masking for that. It will be minimum. It will be minimum number of writes and the last write weight for ith subset. Okay, subset. And suppose we have this subset, right? We have four. Suppose we have this subset, four here only. So for four, we only need one write, and the last write weight will be one only. Okay, and since it is like not crossing the limit, we will have only one write, and that write the weight is four. If we try to add another element to it. Okay, 4, 8, let's say. So for choosing 8 with 4, what we need to check is if there was no 8, right? So if there was no 8 in this combination, then what was the number of minimum rides and the total weight and the weight of the ride? If the weight of that ride can accommodate the new guy's weight, right? So we don't need to update the uh, number of rides, right? So we can just say that mm, so we can just say that yeah, in one ride only that we can accommodate this guy as well. But since 4 and 8 exceeds the maximum weight limit, we cannot have that. So we will have to increase the number of rides. So it will be 2 now, okay? And the last ride weight will be 8 because 8 will be in the second ride. So what we did was we eliminated 8 from here and checked in the state that we had if we state in which 8 was not there the minimum rights and the last weight, and from that last weight we checked if 8 can be accommodated, and then accordingly we increased or kept the same number of rights, right? So for that, what we need to do is basically how the transition will work, okay? Similarly, if we had 4 and 6, right? So in that case, it will be 1 and 6 only, 1 and 10 only. Okay, since 6 can be accommodated and it doesn't exceed the maximum weight limit, so that is why. And if we add another number, if we add this now, then for adding 6, we will need to check for 8 state. So it will be 3 and then 6. Okay. And similarly, if it is 6, 4, 6, 8, see through bitmask, through the subsets that we have, we'll traverse it in a way that we can check. We can check. Basically, we don't need to consider the order from our side. It will be done automatically as we build the answer. Since, like, for example, this one, right? 4, 8, and 6. This combination. The minimum should be 2. Okay. The minimum right should be 2. But here we have 3 and 6. Okay. So suppose we are running okay. So for 4, 8, and 6, how will this recursion or will work? Okay. So for 4, 8, and 6, see that we can choose to add 4 in this, or basically there are three possibilities to add to there are three possibilities to add another person in the combination of two person already present there. So it can be like 4 and 8 and 6, right? Or it can be like 8 in a combination of 4 and 6. Or it can be like adding 6 to the combination of 4 and 8. Whatever gives me the answer, minimum answer, will be considered for this. Okay. So till now, here this guy and this guy, it seems, has given me the minimum answer, and if we add 8 to it, then it will be 2 and 8. It will give me the minimum answer. Okay. But for that, this tree will be considered, right? Before that, we will solve, we will be already, would have already solved all the, uh, like, since we are building from bottom to top, right? So this problem will already be solved. And for 8 6 also, we will have the question of adding 8 to 6 or adding 6 to 8. Okay. Similarly, for this also, we will have the question of adding 4 to 6 and adding 6 to 4. Here also, we will have the question of adding 4 to 8 and adding 8 to 4. So basically, we don't need to consider the order here, since we are already getting the optimal answer from the recursion itself, or the choices we are making in the bottom of DP, right? So we'll start from here and we'll choose the optimal value, optimal answer in such a way that the order will not be important for us. Okay, it will automatically choose the best order for us. So from here, we can see that this whole branch will contribute in the answer for this combination. For this combination, okay. If we add one to it, then it can change. It may not change, or yeah, it may remain the same. So basically, you get what I was trying to explain it. So we don't need to go into the order part of it. We just need to consider this combination. So for that, we can have a bit masking, and that will go from, like, from one to one. Uh, fuck, sorry. So all the combination, right? We'll go through all the combinations and build the solution from ground up. Okay. So that was the bit masking part. Okay. Now how the transition will work. Okay. Transition. Hmm. So the transition, how the transition will work. So for all the members of the that particular combination, we will check what is the answer if that value is not present in that combination. So basically, uh, we'll do the we'll check for the, let's say it is a previous state. Okay, a DP state where uh, where jth element is not present in the combination. Okay, so previous J state. So for the current DP, uh, for the current DP, that will be DP of I only. It will be, we will have two choices again. Okay. First is that whatever last ride weight we had in the previous state, if the current element that we current if the jth element can be uh, included in the last ride itself, so we'll check if the last if the weight of the current element and the last ride weight, so basically dp of previous and its last ride weight, uh, does it exceed the limit. So this is the condition. So in that case, if it does not exceed, then in that case, uh, oh, how do I copy this? Is there no way of copying this? Fuck. We'll have to do it again. Okay. Okay. So we are here. This. So in that case, if it does not exist, then we'll just add it to the then we'll just add it to the last ride only. So it will be minimum of whatever the DP we have currently, and then the DP of the previous one. Okay. Then the DP of the previous one. Of course, since this will be a pair DP, this is the pair DP will hold a pair. So the value and the fact that we have added on the fact that we have added the current weight to the last ride. Okay, so this will be the first transition. The second will be if it does not, like if it exceeds, in that case it will be dp of I will be minimum of dp of I comma 1 plus dp of previous comma we are adding the current weight. Okay, so this is the transition. And answer, where will our answer be? So answer will be in the last combination. So this. Okay. So answer will be in the last combination. And where it will be in the minimum rights. So yeah, this is how the problem should be solved. I'm taking some reference from the last time I solved the problem and also a YouTube video. That is why I was able to solve this. That is kind of pathetic, but you know how it goes. You learn by imitating only. And the fact that I was able to kind of explain it might be the step towards it. So I don't know. NNX will C into NNX. Okay. Now we have the array. Just W. Now we'll have TP and the size will be we need pair. Okay. Okay, all of it should be initialized with what? 29 and 0. Okay. And the initial state should be dp of 0, taking none of the guys. Okay, so of course it will be an empty elevator, so it will go up. Okay, now for all the combinations we are going from 0. 0 has already been done, so from 1 all the way to this. Okay, and of course I will be increased will increase I. And now we need to check for each of the element, right? Okay, so for in okay, for int j is equal to 1, j less than equal to n, j plus plus, and if j is present in I, so that will be this only. If j is present in I, in that case I will need to calculate the previous state. The previous state will be what? The I we had XORing with this. Okay, so we'll check if wj minus 1 plus dp of previous dot second state holds the weight. Okay, so let me do it. number of minimum number of writes last write wait. Okay. So yeah, this holds the last write bit. If it is less than the limit, in that case, we'll update the DP state. It will be DP of previous, comma, DP of previous. Oh, sorry. Plus W J minus 1. Okay. If it is not, then again DP of I will be minimum of DP of I and DP of previous, and we'll need to add one more ride, and the weight will be the last ride weight will be this only. So yeah, after all this, the answer is in DP. Let me, okay, let's just see what happens. N dot first. Let's see how many errors we get in the first compilation. Maybe zero, maybe one. Okay, a lot. Okay, a lot. Holy shit. NB. Silly mistakes. Okay, go up. Mhm. Okay, one. The fuck? Why one? Holy shit. Zero, 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 zero. Okay, so why is it here? So the base case can be that. So the base case. For each case, we may need to take all passengers separately. So that is why it has been done there. But even if I do it, let's just say n plus 1, comma 0, will that solve anything? Yeah, it's the same, right? I can do it here also. Oh, sorry. So what is the difference? Maybe it is this. Okay, it is not. Again, maybe it is this. Okay, it is this. So yeah, the answer is 2 only. I need to do all that properly. Okay, so now that we have solved it with a lot of help, let us just go and submit it. Now before that, I want to see what is the answer. Okay, to stream 42. Oh yay. Your task is to count the number of ways you can fill an n cross m grid using 1 cross 2 and 2 cross 1 tile. Oh shit, bro. I hate this. The only input line has two integers n and m. And you see here, n is 10, m is 1000. 1 cross 2 and 2 cross 1. Fuck it, I'm not solving it today. Counting numbers. Your task is to count the number of integers between a and b where no two adjacent digits are the same. I cannot loop between them. Yeah, this is out of my scope. Yet how did you solve the increasing sequence problem then? Forgot. It was this. So how did you solve projects then? Okay, it was like DP of end date. What is the best I can do by the end of this day, right? So these are some greedy plus DP mix type of questions. Here also it's the same. In this case, we need to add instead of maintaining the we need to see the maximum we need to count the increasing subsequences. Holy shit, it will be hard. So first of all, each number will be counted in itself for the solution in the solution since they are increasing. Since a single element is always sorted type of thing. So, okay. For the next one, nah, bro. These three questions are okay. So one, two, three. I'm going to increase the subsequence as well. Projects also the greedy plus this DP thing, mountain range. All these problems are like you'll if you forget, then you will not be able to solve it. You need to solve it 2 to 3 times at least to be able to remember what the logic was. And here also I'm out of clue, and you can see I've never solved these problems. Last problem I solved was elevator rides, and after that, I think I left it for like maybe like next time or something, but never touched it again. Similarly, counting numbers as well. Never. Uh, I don't think I can right now. I can think of a logic to solve this. It will come to me eventually, but not today. So we'll go to educational DP. First problem. Frog 1. There are n stones. Height of stone is hi. There's a frog who is initially on stone 1. He will repeat the following action some number of times to each stone n. Jump, jump, cost. J is a stone to land on. 10 to the power 5. Hi 10 to the power 4. print the minimum possible cost, total cost incurred to reach the n, to reach n. So here we'll go from 10 to 30, so 20 cost, 30 to 40, so 30 cost, and then 40 to 20. Okay, I can jump to I plus 1 or I plus 2. So if I reach here, I can jump to here or directly here. So if I reach n minus 1 also, that is fine. And if I reach n, that is also fine. For example, here we can just jump to the I plus 2, that is the final, whatever the target is. So it will be 0. Just a second. Okay, we're back. So I plus one and I plus two. So we have two options, and it is kind of simple. So how do we? So how are we going to do it? I don't think we can do it a push TP. Can we do it? Maybe no. Mm, okay, no, we cannot. So the answer will be the minimum of last one or the second last one. Okay, where is the whiteboard? Well, we are done with this. A frog one. Okay, so our frog basically will be jumping from different height of what stones. We have different stones. Maybe this, this, this. So he will be jumping. He can either jump from here or to here, and the cost incurred in jumping will be uh, whatever hi difference is there. So hi minus hj, and we will need to calculate the. Our objective is minimize this. Okay, we need to minimize this. Okay, so uh, yeah, let me do it here. NNH. And of course, we need dp, will be n plus 1. Starting, if n is 0, then the answer is 0. Cannot do anything. Okay, then what if, okay, so the base case for 1 and 2 will be, uh, let's not make it minus 1, it will be h0, and it will be h1. Okay, for int I is equal to 2, I less than n, I plus plus, and dp of I will be the minimum cost, right? Minimum of dpi, and all of it will be 1en minimum I, comma, absolute difference of, we jump from either the h minus 1, in that case we will have hi as a difference, or we jump from I minus 2 So that will have a difference. And of course, since we're jumping from there, we'll need to include the DP for this as well. Let me do it a little. Okay, so this is more visible. And plus dp of I minus 2 and done. We'll do cout dp minimum of dp n minus 1, and what if n is, so n is at least 2, n minus 2. 2. Copy, paste, run. Okay, 40. Why? 30. Should be 40. Okay, we don't need to include this for this. Okay, initially we are at 10 only. So TP of 0 will be 0, not this. Initially the frog was on stone 1 only. Okay, so we are forgetting something. Thirty, 0, 10, 40. Hmm. Interesting. We are not outputting anything else. Okay. Otherwise, atcoder will scream at me. Wrong answer. Wrong answer. Okay. It worked. Second frog. Again. Okay. 10 to the power 7. Okay. We can go. So basically the same code. We'll just have this. We'll take k as the input, and instead of doing this, we'll run. He's in stone 1, right? Okay. He is in stone 1. So I plus 1 till I plus k can jump. Sorry. So for the base case, why don't I do it from here? If I is double equal to 0, in that case dp of I is double equal to 0. Else if I is less than equal to k. So if k is given as 6, then we need to go to 6. Or if I is less than k plus 1. In that case, dp of I minus dp of I will be absolute of hi minus h0. Else for int j is equal to I minus k to j is less than equal to I, not I. J plus plus and dp of I is minimum of dp of I, comma absolute, comma dp of j plus absolute difference of hj, comma नहीं hj minus HI. Okay, this should work. Answer will be in DPF analysis. So let me copy it, paste it, run it. 30. We are getting 30. Here we should get 20. We are getting 20. Here we should get 0. Okay. And in this one, we should get 40. Okay. Working. So let's just submit it. Done, done. Fuck. Yes, I'm a human, bro. Submit. Wrong answer. Wrong answer. Wrong answer. Wrong answer. Fuck it worked. Third, vacation. Taru's summer vacation starts tomorrow, and he had decided to make plans for it now. The vacation consists of 10 days. For each day, Taro will choose one of the following activities and do it on the ith day. Swim in the sea, catch bugs, do homework for 2 or more consecutive days. Find the maximum possible total points that neither Taro gains. For each place, we have two options. So we'll have a DP of we have a 2D DP for position and for whatever activity is planning to do, and that will be that will okay. So uh, mm, okay, so we did the frog 2 as well. It was frog 2, right? Okay, similar to frog 1. The fuck, why can't I write one? Okay. C is vacation. So it is very simple, I think. The our DP will be like this. DPIJ. It is the maximum point okay of happiness, points of happiness till maximum total points till ith day when jth activity is performed. Okay, transition will be similar to, okay, so the base case will be that at 0 day, if he does, it will be 0 basically. Okay, transition is like this: dpi 0 will be basically maximum between the activity point that he can gain. So let's just say for uh, first activity getting, okay, so if it is a first activity, I will not be able to choose. If it is 0, 0 indicates first activity, 0 indicates A, 1 indicates B, and 2 indicates C. All right, so here also let me make a change: this, this, and this. It will be 0, it will be 1, and it will be 2. Okay, this 0 looks very bad. This looks okay. So when I'm at the 0 day, uh, I will not be able to choose A. So I add day and perform 0 activity, then I will not be able to choose A. I will choose B. So let me add BI and then plus maximum. Okay, so no, I am choosing to do this one, right? So, okay, I am choosing to do this one, this activity. So if I'm choosing to do this activity, then it will be like this: AI plus maximum of BP I minus 1. Either I choose the first one or I choose the what second one. Similarly, okay, so I have this. Okay, okay, it will not be 0. This will be 1, this will be 2. Again, I will change a little. It will be B, it will be C. Mm, this will be different. And This will be different. It will be 0, 1, and 0. Okay, so this will be our transition. So we have the base case ready. We have the transition ready. We have our state. The answer will be the maximum. Since we are going with the IMNS, okay. So the answer will be maximum of BP n minus 1, 0, dp n minus 1, 1, or dp n minus 1, 2. Okay, so this will be the answer. Let's code it real quick. Again, n, and we need three vectors, a, b, and c. Vector int a, all of size n, b, n. Okay, I think. Okay, we'll have a dp vector int dp of size n, and again vector int, and will be of size 3, and all initialized with, since you want the maximum, right, 0 will work. Okay, so we'll run the loop from I is equal to 0 to n, and if I is equal to 0, then in that case dp of I 0 will be a0, and dp of I 1 will be a1, p0, sorry, and dp of I2 will be c0. Else dp of I0 will be maximum, or ai plus maximum of dpi minus 1, 0, or dp and minus 1, 2. Just copy this, paste it. And for 2, it will be 0 and 1. It will be for 1, it will be 0. The 1 and 2, 0 and 2, 0, 1. This will be B, this will be C, this will be 1, this will be 2. And answer will be maximum of dp n minus 1, 0, dp n minus 1, 1, dp n minus 1, 2. And we'll just print the answer. Okay, sample output 210. Okay, that worked. 100. What is the answer for this? 46. 46. Verify that you are a human. Submit. Wrong answer. Wrong answer. Wrong answer. Wrong answer. Wrong answer. Wrong answer. Fuck. Okay. Knapsack. So we have 26. We are on third question right now, and I think it is enough for today. We have been going live for almost 1.5 hours, and there were some problems that I'm still not confident with, like the bit masking and the DP plus greedy problems that are on cses. So will learn more about it and again try to solve it. Okay, so yeah, so this is it for the stream. From tomorrow, we'll be doing the atcoder problems. So there's that, and after that, if we are done with the atcoder thing, then we'll move on to the CSS, or else we'll go to lead code, I think. Okay. And in parallel, I'm thinking of going with graphs. So DP and graph. Yeah. Also, I was thinking of what we should do on weekends, since there are no streams on weekends. Because of course it's weekend, everyone likes to likes to uh, take it easy, and you know personal stuff, doing like maybe going home and what all. So maybe uh, we can start learning other things, like maybe concepts of operating system, networking, or even some projects maybe. So yeah, that was just my plan. I have not yet thought of what we should do and on weekends. So that's for future, I guess. And also New Year is approaching, and I'm glad that I've started doing coding again, because see, if I had left it for the New Year, thinking that I'll start solving problems from the first day of the New Year, I would never be able to like learn some of the stuff that I'm doing right now. So yeah, I'm grateful, and also I'm looking forward to solving DP and again reaching the prime that I once had. Okay. Also, I forgot to edit the stream. Sorry. Okay. Uh, it's done, and I think it is time. So I hope you have a good night and peace.